Hello everyone. Today I'll show you how I created the snow generator. I wanted to create a snow scene, and the amount of 3D models that are available in a snow environment is really low. So I needed some way to create snow to apply to my objects in order to make them blend a little bit better with the snow scene. So if you can see here, this scene is composed of a couple of objects that are actually created from snow 3D scans. But the other objects, for example, this one is just a beach rock, and the snow on top of it is generated with my PCG snow generator. So there are some other models, like for example this rock here, which has also this generated snow mesh on top. And as you can see here at the tree, also generated mesh for snow on this tree. And the tree without the snow, as you can see, is some kind of desert tree. So definitely not fitting well into a snow environment. But like this, maybe if you make the shader a little bit darker, it will fit great. And also I used the snow I generated in a couple of other places here in the scene to break up the repetition or the texture of the snow. So as you can see, it turned out very useful to have this kind of generator. So let's check how these meshes are generated. Here I have a blueprint into my level with a PCG graph I created, and I have a setup that allows me to plug any 3D mesh inside here. So let's put a chair, for example, and as you can see, the snow generator generates snow on top of the chair, and I have the option to save this as a model. So let me copy here the path to this mesh, starting for the slash before the game folder. And then let's put a mesh name, for example, snow chair. And let's click this save mesh checkbox. And right after I click it, you can see a dialog appears and it saves this mesh. Let me uncheck it because it will resave it every time I change some settings into this mesh. So now, actually, this is the wrong folder because it's the wrong chair, but doesn't matter. I'll find the proper chair and I'll show you that this mesh will fit the chair. So I can place now this chair. I can find the snow mesh that I generated and I can place it on top of this chair. And as you can see, it fits the same as here. And into the snow generator, you have a couple of PCG parameters that you can use to control how the snow is generated. For example, here I can reduce the value, that's the density of the snow. I can reduce the thickness of the snow, and it will look like a lot less snow is covering the chair. You can see that there is distinct sphere pattern to this snow, and this is because I'm using the sphere mesh just to make it simple for you to follow the tutorial, but I would recommend using a better mesh. For example, you can get snow chunks meshes from Quixel or something like this, and it will look much more natural. But for now, let's continue with the sphere mesh, and I'll just have the thickness set a little bit higher, or I can use the displacement, for example, to make the shape a little bit more random. So let me change something in my snow generator blueprint, and this will help a little bit with the randomness of the look. So let's try like this, and let's increase a little bit the size. So something like this too, and let's reduce a little bit this. So right now you can see it looks much more natural. It doesn't look like spheres anymore, and I'm still using the same sphere mesh. So as you can see, you can get away with just this sphere mesh setup. So let's try to recreate this into a blueprint that you can use in your level to generate the snow. And I wouldn't recommend to use this as a snow generator for big areas. It can work with a couple of objects, but it's very performance intensive. So I would much more rather use it to generate this kind of static meshes with it that you can use then to set dress your level. And you can combine them later into one mesh or something like this, but just be aware that it's not applicable to place it on top of your entire level and generate snow for everything. You need to generate separately for the objects that you want. So let's see now what's the setup and how we can recreate it. So I'll create a new folder here just to start fresh. So let's call it snow tutorial. And let's start first by creating the PCG graph. Right click, search for PCG and create the PCG graph. I'll call it PCG snow tutorial. And into this tutorial graph, let's check the other graph first, and I'll do the same. But if you have watched my tutorial about generating meshes for doors and windows cutting into the walls, you'll be familiar with a lot of this setup. And I'll put a link into a card in the video in the top right corner, so you can check the video if you didn't watch it. But I'll now recreate part of the graph, and I'll explain how it works, so you can follow even if you didn't watch it. So first we are generating some points. I'll show you how. And then if we have this spawn snow boolean set to true, we are generating a dynamic mesh, which is done with the PCG and geometry script integration. So to follow this tutorial, make sure that you go into your plugins settings. So go to the edit menu, then the plugins, then here search for PCG and make sure that you have loaded the Procedural Content Generation framework, which is PCG, and the geometry script interop, because you'll need the PCG to generate the points and the geometry script to create the snow. So let's continue now. We'll use the PCG geometry script nodes to create a dynamic mesh, and we'll create this custom blueprint node that will generate the snow from this dynamic mesh. Then we'll spawn the dynamic mesh into the level, and if we have decided to save the mesh and if we have the proper name and folder, then we'll save the dynamic mesh to an asset. So let's recreate this. First, the part with the saving, because it's already done in the previous video, so it will be a refresher for you. So let's start with the PCG graph that we just created. So I'll drag this into the level, and let's frame it as so you can see here into the left part what we are doing. So let's search for dynamic mesh, and these are some of the different nodes that come with the geometry script interrupt with the PCG. So let's start with spawn dynamic mesh, or actually static mesh to dynamic mesh element. And let's choose some static mesh. In our case, it will be a sphere. So let me find it. So it will be this sphere. It's into the engine folder, so you should have it. So now I have this dynamic sphere. And if I debug this with the D key, you can see I'm getting this sphere into the level. But this is showing into the level only because I'm debugging this node. So if I click here the debug, you can see the sphere. If it's not the debug, you don't see the sphere. So in order to have it in the level, not just with the debug, we need to spawn dynamic mesh. So this is spawning our dynamic mesh into the level. And now how to save this into a file. Let's reduce this window so we can see our folder here below. Like this. So now let's do a branch node. Let's connect this mesh into our branch and we'll create a parameter into our PCG graph. So click here into the graph settings, scroll down a little bit into the parameter section, click on the plus sign and create a parameter, and we'll rename it and we'll call it save mesh, and we'll change the type to boolean and the default value will be false. So let's save this PCG graph. And now if I minimize this window, if I go into the level, you can see for our graph, we have our PCG component, then the settings, then the graph instance, then into the instance, we have this parameters override and we have this save mesh. And if we click here onto the checkbox before the parameter name, this means that we can override this parameter. So we can set the value to true or false of this save mesh parameter. So now let's get it into our PCG graph. So get save mesh. This is the parameter that we just created, and we'll connect it here into the output B. So this output B we'll use if this save mesh is true, it will output through the B node here of this branch. And what we want to do is to save dynamic mesh to asset. And the asset path will just copy the folder that we have currently from the / before the game folder. This is the asset path, and the asset name, we'll call it snow mesh, for example. And you can create parameters for this, like we created for this save mesh. For example, let's say we'll save all of our snow meshes into this snow tutorial folder. So I'll not create a parameter. This will be the value always. I will just create a parameter for the name of the mesh. So let's again click here onto the graph settings of our PCG, create a parameter. Let's call it mesh name. And let's change the type to a string. Let's save it. Let's put a default name of snow mesh, for example. Let's save it. And now let's connect it by getting mesh name and connecting it into this asset name. And this save dynamic mesh to asset node. Let's check the settings. Let's uncheck this open save dialog. This means that it will not open the dialog to ask you where to save it. It will just use the settings that you entered here. So the asset path is our snow tutorial folder, and the asset name is snow mesh that we just created. So let's save this. And right now, you can see that no matter what I do here into the level with this PCG graph, if I generate it, clean it, generate it, nothing happens. But if I click this save mesh, because I have this snow mesh name here and this path of my folder, I have created this snow mesh static mesh into my content browser here. And I can use this as any other static mesh. So now let's see how we can override the name. So again, select the graph into our level, click here onto the mesh name and change this to, instead of snow mesh, let's call it sphere mesh. And uncheck and check this save mesh. And now we have this sphere mesh created. Let's delete these two meshes. Let's uncheck for now this save mesh. And now you know how to create this part where you save the mesh to specific path and with specific name. And here into the other graph that I showed you, it's a little bit more complicated because I'm creating a variable for the path and variable for the name, and I check if they are not empty, but you don't need that. Just make sure that you enter the name and the path correctly into your save mesh to asset, and everything will be fine. So how we can continue with creating this PCG graph to generate the snow on top of some object. So let's start first with deleting this graph into the level, and we'll actually create a blueprint. So right click in your content browser, create a blueprint class, and then create an actor type and call it BP snow tutorial, for example. And let's open this blueprint. Inside this blueprint, I'll create a PCG component. Let's compile and save this, and this PCG component, I'll connect the PCG graph that we just created into this graph field into the details panel. So let's compile and save this. And the other thing I'll add is a static mesh component. And this static mesh component, for now, let's create a sphere. So we just have something into the level when we place our static mesh, our blueprint. So let's place our blueprint now into the level, and you can see that it creates this sphere into our level. Let's open the PCG graph that we created, and let's start with creating world ray hit. And this world ray hit will connect with a surface sampler. And if I inspect this surface sampler by marking it and clicking the A key, and here I select the instance into my level, you'll see that no points are being generated. So let's change now the points extent to something very small, so 0.1, 0.1, 0.1, and the points per square meter to something big like 100. We're generating 100 points for every square meter, and they're very, very small, so they should be able to fit onto our object, but still we don't have, we don't have anything in when we inspect this node in the graph. So let's see what the problem can be. So the problem is that we don't have any bounding box shape into our level that will tell it where to search for this surface. So let's add a box collision into our blueprint, and this box is a little bit too small currently. So let's make the box extends a little bit larger. So let's say 300 into every direction. Let's compile and save this. And now if we go back into our PCG graph, you can see that we are now generating points. We have 3,400 points or something like this. And if we debug this by clicking the D key, and let's actually do a extends modifier after it, because currently it's a very, very small points, so we cannot see them. So debug this extends modifier, and we still cannot see the points. If we move the camera a little bit down, you can see that the points are generated, but they're on the ground. So let's select this world rate hit, choose the filtering tab here into the details panel, and let's not include the landscape hits, because we want the snow generated to be only on top of our object that we connect. So for the select landscape, choose exclude. And now we don't have anything into the level like we had it before, but we want to have points on our sphere. So let's go back into our blueprint, and into our static mesh, let's search for collision. And you can see that the sphere is set to block all dynamic. And into our PCG graph, the world ray hit, if you open the advanced tab here, is set to world static. These two settings needs to be the same. So if we choose to use the dynamic collision for our sphere, here we need to change it to world dynamic, and you can see that the points starting to appear on our sphere. or even better, just use the inspect key, so you have the list of points here. So this is a much better method always, because if you are using the debug, the points may be too small, or they may be in some other part of the level that you don't see. But if you use the inspect with an A key, you can see the points here into the list. And if you double click some point, it will move the viewport to this point and it will show it to you. So make sure that you are using the inspect option as well as the debug options to locate your points, not just only one of them. And now that we have the points generated, actually let's first go back and change the collision to block all of the sphere, because I want to use the static channel, not the dynamic channel, because all the object that we get from Megascans or something like this will have by default this block all collision, which is a world static channel. So let's save this, compile and save this blueprint. And right now we have a setup that generates points on top of our object. Let's add the functionality to change this object. So into our blueprint, let's add a variable, and this variable will call mesh, and it will be of type static mesh, and it will be static mesh object reference. Let's compile and save this. And for this mesh variable, let's choose default value. It's not the proper type I want, so let's choose static mesh, and it should be static mesh object reference. Compile and save this, and now it's fine. So you can see now I have the option to choose default value here for the this variable, and I'll choose this sphere like we had it before, this one. Compile and save, and I'll make it public by clicking here the I, or here the instance editable checkbox to true. So compile and save, and if we go back into our level, you can see now we have this mesh variable to change into our blueprint. So let's again open the blueprint, let's go into the construction script, and for our static mesh component, let's set static mesh and choose this into the component section, static mesh, set static mesh. Let's connect this on construction, and let's connect the new mesh with our variable that we just created called mesh. Compile and save this. And now if we go into our level, if we change the mesh variable here to, for example, the beach boulder from before, you see that the mesh changes, but here we still can see the sphere, and this is because into our PCG graph we are spawning the dynamic mesh, this sphere that we are creating here. So instead of creating this sphere, let's delete this, and you can see now into the level we are having this boulder connected and the points are projected onto the boulder. But in order to spawn dynamic meshes on these points, let's again right click, search for dynamic in order to see the nodes for the geometry script interop plugin. And now let's choose append meshes from points, because we want on each of these points to have this kind of sphere. So we need a dynamic mesh to connect here for the dynamic mesh input. So let's create empty dynamic mesh. So right click, create empty dynamic mesh, connect it here into the dynamic mesh field. Connect the points that we generated to the in points. So now into a empty dynamic mesh with this append mesh from points, we'll set a static mesh that we'll choose here, and this will be again the sphere that we use to create this snow effect. So we'll append this sphere, And let's move everything here at the end. We'll append this sphere to each point, and let's then spawn a dynamic mesh. And you can see that we have some spheres spawned, but they are not on the right place. So how can we move these points on the right place? We need to actually apply some transform offset. So let's get our actor position by get actor data. This actor data will be just a single point. So here into the data retrieval settings, set the mode to single point, and this will give you the position of our current actor. So let's do a subtract node after our points generation and connect our actor data. And into the subtract, we'll use the position value for both inputs. So we'll subtract the position of our actor from the position of every point, and then we'll connect it to this in points. And you can now see that these points are generated on top of our boulder. They are very, very, very big. So the problem is that this sphere is huge for snow generation. So what we'll do before or after repositioning the points is we want to scale them. To scale them, let's create another variable into our blueprint for generating the snow. So let's add a variable and call it snow thickness, for example, and this will be a float variable. And we'll make it public again. We'll make a default value of 4 centimeters, let's say. And let's change the slider range so we have some values to work with from 2 to 20. And the value range for 1 to 40, for example. This means that the slider will work with these values from 2 to 20, but if we input some other values, we can actually make a bigger range. So we are not limited just by the slider. So let's save this and go into the PCG graph. Actually make sure, yeah, it's public, so let's copy the name. We are sure that here into the PCG graph, when we get actor property, this get actor property, here the property name will be the snow thickness that we just created, the variable from our blueprint. And right now, we'll use this, we'll divide it because our sphere, as you saw, is very, very big. So we need to divide this value, let's say 100 times. So create an attribute. And this attribute will have a value of 100. Let's connect it here. And let's create a multiply. So let's use this multiply with this value. And the value that we want to multiply will be the scale of these points. So you can see we are now reducing the size of these points. And if we go into our level here, and if we change our thickness to 5, 6, 8, 10, 20, you can see we are increasing the size by controlling this variable here. So this looks good for now. So we are generating some spheres right now, and we are spawning them like a dynamic mesh into our level. And we have the option to save this dynamic mesh to a file. But it doesn't really look like a snow still. So what we want to do is convert these different spheres into a mesh that looks like snow. So to do this, we need to actually create a blueprint, custom blueprint node into our PCG graph. So let's right-click into our content browser, create a blueprint class, and this blueprint class this time will not be an actor, it will be PCG Blueprint Element. So here, search for this PCG Blueprint Element, and let's call it PCG Blueprint Element Snow, something like this. So into this PCG Blueprint element, we need to overwrite some functions. So into the functions field here, select the override dropdown and choose the execute with context. Let's compile and save this. And the execute with context will be run when we connect our node that we are just creating. So let's go into our PCG graph. Let's drag inside this blueprint node that we created. So you can see this is like a regular PCG graph node, but it's created by us and it's a type of PCG blueprint. So let's go back to the blueprint that we just created. And what we want to do is first into the class defaults here, into the input and output. Let's uncheck this has default in pin and out pin. And let's create actually one input pin, the custom input pin, and one custom output pin. And the type for both of them will be dynamic mesh. So we'll have an input dynamic mesh and we'll output a dynamic mesh as well. So let's compile and save this. And if we go back into our blueprint right now, into our PCG graph, you can see that they changed to this magenta value, so, or purple, I'm not sure which one is it, let's say it's purple. So this is the color for the dynamic meshes, as you can see here into this node. So we can connect the dynamic mesh to this, and we can work with this dynamic mesh value inside this blueprint, and at the end we'll export again a dynamic mesh, but it will actually be the snow value. So this will come here before this spawn dynamic mesh. We'll get all of our spheres and we'll spawn snow instead of them. So currently we don't do anything, so you can see that it stopped working. So if we go into our PCG graph here, let's get the input value that we have. So I can show you the one I created earlier. And you can see that how it starts. So first we are getting the inputs. The first input, so the input with the target 0, will match the input that we created here. So this dynamic mesh input. So let's drag out of our input, choose get inputs, and this get inputs will be an array. So we'll get the first one. We'll get a reference for the one with the index 0. So this is the first one. Then we'll cast it or break the PCG tag data first. And the data will cast to PCG dynamic mesh data. And this PCG dynamic mesh data will then save into a variable. So create a local variable and call it PCG dynamic mesh input, or PCG dynamic mesh is fine. And the type will be PCG dynamic mesh data. So this one, object reference. Let's out drag it here into the blueprint and let's set it to this value here. We are saving into this variable the PCG dynamic mesh that we are inputting. And after we save this, let's create a sequence node. After we save this value, so first this sequence is running first this, then 0, and after it's done, let's then output the value that we want. So the value that we want to output will be this dynamic mesh that we got into the input. We'll make PCG tag data. Then we need to make an array. And from this, make PCG data collection. Because the value that we need to output is PCG data collection. So let's connect this now and let's compile and save this. And you can see that we started to get again these spheres into our scene. So currently our node doesn't do anything. It just get the input, save it into a variable, and then we use this variable to output the same thing that we input. So in between these points, so let's add another pin to this sequence, and let's connect the last one to the end here. And the middle one, what we'll do is first let's generate a single mesh from all these points. And we'll use this variable that we created. Let's drag it here. Let's get the dynamic mesh from it. And this dynamic mesh, let's apply mesh morphology, this voxel operation. So let's connect it here. And let's split the options. And split this mesh grid parameters as well. So here we have an option distance and this mesh grid parameters grid cell size. So let's increase the cell size to something bigger, like 2. We don't want to have very small voxels because it will be very hard for it to compute. So increase this mesh grid parameter cell size to something like 2 or even 4 for now. I think it will be fine. And this option distance, let's leave it for now to 1. So let's compile this. And you can see that we start to create this single mesh from all these spheres. Let's increase this distance to something bigger, like 4, and compile. So you can see what happens. So you can see that this is like an extrusion to the spheres. So if we increase it to 10, you can see it's even bigger. So it's something like a thickness modifier for the meshes. And we already have such variable into our blueprint, this snow thickness. So let's go back here and create a variable into our PCG graph and call it thickness. And it will be a float variable. And right now, if I go back into my PCG graph, if I open this spawn, not this spawn dynamic mesh, but our custom graph, this one, PCG Blueprint Snow, we can connect our thickness variable, which was this one, get actor property, snow thickness, the same we used before for the sphere size. I'll connect it here. So let's make sure that this is compiled and saved. And right now we have this thickness input. So if you don't see it, open with this arrow the node that we created, connect it to the thickness. And now if I go and change the thickness value, let's connect it here as well. So we'll use our thickness for our options distance. So compile and save. And if I go back here into the level, if I change the thickness to something like 2 or 3 or 4 or 5 or 6, 7, 8, 9, you can see it changes the thickness of the snow that we generate onto this object. Let's go back to 2, or actually let's do a 5, something like this. So this looks fine for now, but you can see that we don't have a proper material. It's just this gray default material. So let's go back into our blueprint. Let's create another variable for our material. Let's call it material instance. And let's change the type to material instance. Let me show you a little bit better here. Material instance. And here change to object reference. Make it public. And now we have the option into our level here to connect a material. And let's put some default material. I have some snow materials downloaded from Quixel. This one. Let's compile and save. And currently it doesn't do anything. We need to go into our custom node here. And here, before our return node, let's actually get our dynamic mesh element. Let's set materials. And this set materials needs to have an array of materials. So we'll here expect again a material input. Let's call it material instance as well. And the type will be again material instance. Let's compile and save, make it public. Let's make an array from this material instance because this node expects an array input. So connect it like this. And if we go into our PCG Snow tutorial, we'll get actor property, but this time it will be the material instance property. And we'll connect it here to the material instance input of our PCG custom blueprint node. And now, if you go into the level, you'll see that our material is being applied. But if you look closely, you'll see that there's some problem because everything just looks white. It doesn't have any details for the material. So let's go into our blueprint snow and check what can be the problem. So problem most probably is that when we generate this mesh, we don't have a proper UV map for this object. So let's set up UVs for this object. So drag out of here and set UVs from planar projection. And let's split the pin for this transform. The scale to 1. Let's check how it works like this. So compile and save this. It doesn't look it's working fine. So in order to set the size of this projection, let's get our actual object that we generated. So this dynamic mesh object. Let's get the bounds for this object. And the bounds, let's break them. So let's subtract from the max, we'll subtract the min, and then actually let's split this and we'll get the maximum value from the x or the y. And when we get the max value, let's split this scale and connect this to all of the values. So compile and save. And right now you can see that we started to get proper UVs for our object. So let's see right now what we can change here. So let's reduce the thickness to 4. And you can see it looks a little bit too much like the spheres that we are inputting here. So in order to fix this, let's first go back into our PCG graph. So here, after we change the scale to something smaller in order to not have this huge spheres like we had before, let's actually reduce the Z value of our spheres so they are not so round, they're a little bit squashed into the vertical direction. So let's do a multiply again to the scale, but this time it will be only scale Z, and we'll multiply by another attribute. So use create attribute and we'll do 0.5 or even 0.25, something like this. So if I increase this to 1, you can see it's much bigger, much thicker, but 0.25, it's a little bit better, so it's squashed into the vertical direction. It's not so much like a sphere. And the other thing that we can do is go into our blueprint node that we created, and after we apply these UVs, let's apply displace from texture map. And this texture map is again texture from Quixel. So let's search for snow, and this is this snow displacement map. So this is from the fresh snow material from Quixel. You can get it from FAP. Just download the texture for the displacement. And right now, if I split here the options and I increase the magnitude to something like 5, for example, let's compile this. You can see that it starts to displace this. And let's make actually a variable for this magnitude. Let's right click here onto the magnitude. Let's promote to a variable. And let's change the name instead of options magnitude to be displacement strength. And let's make public value. And here into our blueprint for the tutorial, let's make here a variable as well. Let's call it displacement strength. And let's make it a float variable, public, compile and save this. And let's make default value of 4. The range will be 1 to 20. And the value will be 0 to 50, for example. Compile and save this. And if we go into our blueprint, we have this connected, but in our PCG, we need to get actor property. This property will be this time displacement, or how it was called, displacement strength. Let's copy this and paste it here into our PCG graph and connect it to the displacement strength of our blueprint node. So right now we can go here into the level and change this displacement strength and this node thickness. And by combining these both values, we can create more randomized look of our snow. Something like this, for example. And one important thing that I want to stress for this generating snow function is that the object that you want to generate the snow on needs to have collision, of course, and needs to have collision that's very much aligned with the actual shape of the object. So what I mean by this is if I go to this object and if I open it, you can see that currently I have it set up with the collision value, or actually let's search for complex. So the collision complexity, I have used this use complex collision as simple. This means that it will use the mesh of the object, so the actual geometry of the object as a collision. So this will make the snow very, very good at conforming to the shape of the object. Because if we change to the project default, and if we check now here into the show simple collision, you can see that the simple collision for this object is very far away from the actual shape of the object. So if I save this, and if I go back here, let me regenerate the PCG graph by selecting the PCG here and clicking generate, or let's clean up and generate. So you can see right now this snow doesn't actually follow the shape of the object, it's following the shape of this collision. So You can see it's very, very far away here from the object. So when you're using the generation of the snow graph, you can temporarily use this use complex collision as simple, because this will generate much better snow mesh. And after you save this snow mesh, so let's save this now here. So select this, go into the PCG graph settings, and here let's select a name which will be snow mesh rock, for example, and we'll choose snow mesh, the save mesh, and click save here. And if we go to our folder which we set up to have our mesh saved, so this is the mesh that we currently generated. So after you have the snow mesh generated, you can go back into your object and remove this use complex as simple. Just go to the project default, which will make your collision much more faster to run into the other parts of the game that you have. You'll just have this snow mesh on top of your object. So as you can see here, if I place this object into the level, let's duplicate the object so we can use the position by just replacing it here with this mesh. And you can properly place it a little bit better here, something like this. So you can see now I have this very, very good conforming to the actual model mesh of the snow. But if I check the player collision graph here, it's just a very simple collision box. So it will run much faster into your level, but the generation of the snow is created on this detailed mesh, so you don't have any problems with the actual look of your object. And here, of course, you can change to some other mesh. So the chair that we used, for example, earlier, like this, you can see the snow is generated on the chair again. And you can add any additional options that you want. For example, you can have smoothing, or you can have random size of the points, or any other additional feature. So I'll not bore you with much more talking on how you can do that, but basically if you want to change the position of something, you do it here into the generation of the points. And if you want to change some actual property of the mesh that you are generating, you go into the custom blueprint node that we created, and you can add, for example, here some other node, like for example, smooth. So apply iterative smoothing to the mesh. Let's connect it here to the target mesh. Let's split here to see the options, and 10 is too much smoothing, so let's say 2. And if I compile this, you'll see that it will smooth this mesh a little bit. This mesh is a little bit too round in order to see the difference of the smooth, but yeah, if you have, for example, let's do the smooth after the displacement so you can see the result a little bit better. I would not recommend this because it doesn't make sense to displace it and then smooth it, but I just want to show you that you can apply some different transforms here into this blueprint. So you can see now we are smoothing. Let's increase it to 5. Compile. It's even smoother. So depending on the mesh that you use, maybe you're not using this sphere. You may want to smooth the result before you apply this texture map displacement or something like this, but I believe that this should be fine. So Some other fixes that you can do here is to have control over the UV of the object. So you can create another variable here. Let's call it UV scale. And let's change this to vector 2D. Let's make it public. And let's connect it now here into the options UV scale for the displacement. After you set the UVs, let's set UV scale mesh UVs. And let's use the same UV scale here. Okay. So now this UV scale, let's have a default value of 1 and 1. Let's compile this, and if we go back into our PCG Snow tutorial version, and maybe even to our blueprint, let's create a UV scale variable here. Let's copy the name, make it a vector2 type, vector2D. Let's compile and save this. And if we go into our PCG graph, here we need to get actor property, paste the name here, UV scale, make sure that it's public here into our blueprint. And right now, if I connect it here and save this, now if I go back into the level, I can control the scaling of the UVs by this UV scale parameter. And let's set up the actual default to be 1 and 1, because the UV scale should be defaulting to 1. And right now, if I want to have a much more denser texture, I'll change to 2 and 2, or if I want to have it much more loose, 0.5 and 0.5. So depending on the size of the generated snow, for example, I'll reduce thickness here. I'll add some bigger mesh. Let's say I'll do this border again. So for this border, we are currently using this simple collision, so it doesn't look very good, but just watch for the texture. If I change now the scale to 5 and 5, it's too much, but 2 and 2, it's much more good for the size of this texture compared to the one on the chair. So you can use this displacement value as well here to have a little bit more randomness. So I hope that this gives you idea how you can generate different type of meshes with PCG and use them to set dress your level better. You can add tons more functionality to this, but in the time I have for this tutorial, that's all I can show you. If you have any questions, write in the comments. And guys, please like the video if you like it, and subscribe for the channel if you want more tutorials like this. You can join the channel, and into the higher levels, you can watch the tutorials earlier, so you can ask your questions earlier and get some answers before everybody else. So guys, I'll see you in the next one. Bye.